Welcome. Today I am going to show you one of the most interesting software if you are highly interested to work on metamaterials, and that too in triple periodic minimalistic surface. We all know that triple periodic minimalistic surface, example gyroid, they are very highly interesting surface with a lot of application in various fields. But due to the complex shape of these structures, it is very difficult to create them using any CAD service or CAD software tools. So to make it more simple, there are some commercial softwares which make it more simple to create them. But in general, these softwares are proprietary and tend to be highly costly. So to help the researchers and also students, Lattice comes in the picture. It is an open source and free software which gives a very huge chances for whether it be academicians or students to generate triple periodic minimalistic surface and use the codes inside them to more modify it and use it for their purpose. Lattice can be used in many different disciplines, whether it be in tissue engineering, lightweighting, heat exchanges, and in additive manufacturing. So Lattice has an interdisciplinary advantage for many fields. These are the major four features which Lattice can give, that is variable density, hybridization, cell size grading, and hierarchical. Here these major four things cover maximum requirements of the design of the triple periodic minimal surface, and these all four are provided by the Lattice Karak. So you can see what are these four features and how they help. In variable density, what we try is that we control the density. So that is that too here linearly from one particular value to one particular. For suppose here you can see from 90% to 10%. Whereas in cell size grading, we try to keep the density common, but the porosity keeps on changing linearly. That is from one level to another. Whereas in hybridization, what we do is that we try to make a new lattice structure which is a union of two different lattice structures so that we can get the best of the both two lattices. Whereas in hierarchical, we try to create more, that is we go one more step forward. That is here we try to create second order TPMS, that is majorly to control the properties, that will like tailor the properties at particular places. So we are seeing the functions. Then let's see how we can install this Lattice Karak. Installation, you can see the GitHub link. Once you get the click on the link, you can download the .exe file. Once downloading, you can see this thing here in the required wherever you download image drive. Then after double clicking it, the installation will automatically start and it gets done. It takes like 2-3 minutes or some more time depending on computer, but once the installation is done, the software automatically runs. So this is the UI of the Lattice Karak. Here you can see the tabs: simple, variable density, cell size grading, hybridization, and hierarchical, where each tab gives you the required features. So let us start with simple. Here simple means like generating the basic triple periodic minimal surface. So here you can see the cell parameters. See what does it like? It says like number of parameters you need to, like how many number of cells you want to give in each direction. Let us say give like 1 in x direction, 2 in y direction, 1 in z direction. And level set is generally used to control like the thickness of the triple periodic minimal surface. For that you can use. And second is the, here you can see function like what you want to choose, whether it be gyroid, double gyroid. So you can choose the required TPMS from this. Sheet or skeleton is again a small sub classification triple periodic minimal surface. Once everything is done, you can simply plot. So it runs. You can see here it has generated like 1, 2, 3. For suppose I'm again changing, I'll keep as 1, 1 in each one, then plot. That's it. So you can see as perf 1 gyroid. So now I designed the gyroid, but I need to store it. So like store it in the sense, and that too in a printable format. So that's a STL format. Simply click on the export button. you'll get all the options. Simply you can go to the required file you want to see, and you can save as gyroid. Done. So it will be saving in gyroid. That's what it does. Then you can go for variable density. Here variable density, as I told you, like the density keeps on changing, that too linearly, as we go from starting to ending. So same thing, you can adjust your parameters. Let us keep like 3, 3 and 3. You can choose the direction which you want to make like vary. So let us start from 20 and let it go for some 80. Same gyroid and same thing, you can change sheet or scale type your wish. Plot. So it is running. Once it runs, you can see here now it's changing from 80 down to up 20. So in this way it's changed. Same way you can keep on exporting. Then coming to cell size grading, here also it is same. Simply here what you will be doing is like you will be inputting the number of cells starting and ending row. Let's keep 2 and 4 itself. Cell level set to control density, and whatever function you want for gyroid, or let us go for SP. Then you can click plot. So the program runs. You can see red button. Once the program has run, you can see here starting there are 2, that is bottom, and at top it became 4. So it's how it keeps on changing. Same way, by clicking the export, you can save it in your record folder. Then coming to hybridization, here what we'll be doing is that we'll be trying to make one structure containing 2 different structure. So cell parameter 1 controls the function 1, cell parameter 2 controls the function 2, level set is control the density. So let us follow same number of cells, and this is the function, and you can keep your required direction. Sigmoid function shows like how much each parameter is given. Now let us keep 3, and then you go for plot. You will get a one lattice structure which is made up of gyroid, that is down, and that is SP. Now you can see if I made it into 5, then the amount of, there's a change in amount of the gyroid. So that's what it changes. And even you can go for X direction to get more perfect picture. Yeah, done. So that's how this everything is done. So that's for hybridization. Then coming to hierarchical, here what we'll be doing is like inside a big structure we'll be making another small structure. So for suppose I'll make a gyroid inside gyroid only, so we can call it a second order gyroid. Let us keep somewhere here level set, both are this plot. So I'll be getting a gyroid, a one, you can see outer one is a big gyroid, but inside it is made up of some more small gyroids. That's what it does. So this is the overall view of the lattice karak. With this you can design like maximum all kinds of triple periodic minimal surface. So thank you for watching. I hope you will download the Lattice Karak and use it in your studies. Thank you so much. And your suggestion and comments are highly appreciated. Thank you.